Today's session is about Hungarian method. It is one of the methods to solve assignment problems, which is seen in operation research. Today we shall discuss about unbalanced assignment problems. Approach. First, check for balance, that is the number of rows is equal to number of columns. If not balanced, then it should be balanced by adding a row or column with dummy entries before applying the algorithm. Step 1. Row reduction matrix. Subtract the smallest cost element of each row from all the elements in the row of the given cost matrix. See that each row contains at least one zero. Step 2. Column reduction matrix. Subtract the smallest cost element of each column from all the elements in the column of the resulting cost matrix obtained by step 1 and make sure each column contains at least one zero. Step 3. Assigning the zeros. Draw minimum number of horizontal and vertical lines, n, to cover all zeros. Examine each row. If number of zero in the row is 1, then mark it and delete the corresponding column by drawing a vertical line, and if number of zero in the row is maximum, that is more than 1, then skip. If all the zeros are not covered by the lines, then column examination is done. Examine each column. If number of zero in the column is 1, then mark it and delete the corresponding row by drawing a horizontal line, and if no of zero in the column is maximum, that is more than 1, then skip. Step 4. Apply optimal test. If each row and each column contain exactly one marked zero, then the current assignment is optimal. Minimum number of horizontal and vertical lines drawn, n, to cover all the zeros. A. If n is equal to n, where n is the order of the matrix, then an optimal solution can be made. B. If n less than n, then go to next step. Then go to next step 5. Step 5. Modify the matrix. Determine the smallest uncovered elements x. Write uncovered value is equal to uncovered value minus x. Intersection value is equal to intersection value plus x. Line value, that is other value, are same. Step 6. Repeat steps 1 to 5 until an optimum assignment is obtained. Let's understand with an example. Solve the following assignment problem shown in table using Hungarian method. Solution. In this matrix, these are jobs and these are machines. First, check for balance, that is whether the number of rows is equal to number of columns. Here 5 jobs and 6 machines. Problem is unbalanced, that is non-square. Balance the matrix by adding column with dummy entries. Now, matrix is of order n is equal to 6. Step 1. Subtract the smallest cost element of each row from all the elements in the row of the given cost matrix. See that each row contains at least one zero. Here smallest element in all rows are 0, so difference of the numbers is same. The matrix obtained is this. Step 2. Subtract the smallest cost element of each column from all the elements in the column of the given cost matrix. See that each column contains at least one zero. Smallest element in first column is 4. So, 12 minus 4 is 4. 4 minus 4 is 0. 14 minus 4 is 10. 12 minus 4 is 8. 18 minus 4 is 14. 8 minus 4 is 4. The smallest element in second column is 4, so 4 minus 4 is 0. 10 minus 4 is 6. 16 minus 4 is 12. 4 minus 4 is 0. 6 minus 4 is 2. 14 minus 4 is 10. Smallest element in third column is 6, so difference of the numbers is 10 minus 6 is 4. 16 minus 6 is 10. 12 minus 6 is 8. 6 minus 6 is 0. 16 minus 6 is 10. 8 minus 6 is 2. Smallest element in fourth column is 4. 4 minus 4 is 0. 4 minus 4 is 10. 8 minus 4 is 14. 8 minus 4 is 4. 18 minus 4 is 14. 12 minus 4 is 8. Smallest element in fifth column is 10. 12 minus 10 is 2. 14 minus 10 is 4. 16 minus 10 is 6. 10 minus 10 is 0. 14 minus 10 is 4. 16 minus 10 is 6. The smallest element in last column is 0, so difference of the numbers is same. We get this matrix. Step 3, assigning 0. Draw minimum number of horizontal and vertical lines, n, to cover all zeros. Examine each row. In this first row, there are more than one zero, so skip the row. In the second row we see 2 zeros, so skip this row. In third row only 1 zero, so we mark it and delete that column by drawing a vertical line. Fourth row, 4 zeros, so we skip it. Fifth row and sixth row, no zero left. Now we see zeros uncovered by lines, so we start column scanning. First column, only 1 zero, so we mark it and delete that row by drawing a horizontal line. Second column, 2 zeros, skip. Third column's only 1 zero, so we mark it and delete that row by drawing a horizontal line. Fourth column, here we see only 1 zero. So mark it and delete the corresponding row by drawing a horizontal line. Fifth column, there is 0 but this 0 is covered by line. Sixth column is already deleted. Check whether all zeros are covered by lines. Here all zeros are covered by lines. Note, if not, we will have to diagonal scanning. Now, in this problem all zeros are covered by lines, so we got to next step. If n is equal to n, where n is the order of the matrix, then we get an optimal solution. Here n is 4 and n the order of matrix is 6, so go to next step 5. Identify the smallest uncovered elements x. Add x to the intersecting values. Subtract x from uncovered values. Other values being same. Here in this case, the smallest uncovered elements x is equal to 2. Add 2 to the intersecting values, this and this. Then, subtract 2 from uncovered values, 10 minus 2, 8, 12 minus 2, 10 so on for all values. Other values being same. Now, next step is to scan the row and column again. Row scanning. First row more than 1 zero, skip. Second row, only 1 zero, so we mark it and delete that column by drawing a vertical line. Third row, only 1 zero, so we mark it and delete that column by drawing a vertical line. Fourth row, 3 zeros, skip. Fifth row, 1 zero, so we mark it and delete that column by drawing a vertical line. Sixth row, 1 zero, so we mark it and delete that column by drawing a vertical line. Now, column scanning. First, second and third column, vertical line is there, so go to next column. Fourth column, 1 0, so we mark it and delete that row by drawing a horizontal line. Fifth column, 1 0, so we mark it and delete that row by drawing a horizontal line. Sixth column, vertical line already present. Now check whether all the zeros are covered by lines. Here, n is equal to 6. N is equal to 6. N is equal to n. So optimal solution is possible. Where the optimal assignment, machine and job is as. First machine job 4 times taken 4. Second machine job 1 times taken 4. Third machine job 6 times taken 0. Fourth machine job 5 times taken 10. Fifth machine job 2 times taken 6. Sixth machine job 3 times taken 8. The optimal solution, total minimum times required is equal to 4 plus 4 plus 0 plus 10 plus 6 plus 8 equals 32 hours.